Welcome to clickmyproject.com. Let us discuss about the error analysis for high data rate applications using Welch power spectral by cognitive radio users. Let us discuss about the abstract of the product. So the increasing demand of wireless applications has put a lot of limitations on the use of available radio spectrum is limited and precious ratios. So some of the frequency band in the spectrum are unoccupied, some of the frequency band less occupied, and few bands are overutilized. So cognitive radio system is a technique which overcomes the spectrum underutilization. There are mainly two tiers of users in cognitive radio model. One is primary user, another one is a secondary user. So the primary user or licensed user have the rights of priority in using certain stable frequencies band or for communication. So the secondary users are allowed to use the frequency spectrum monetarily only if they do not interfere with the primary user. So the function of cognitive radio is called a spectrum sensing, which enables to search for the free bands of the occupies. So in the proposed work, cognitive radio system is a technique which overcomes the spectrum underutilization by using the spectrum sensing algorithm. So that is a bit error rate is considered for cognitive radio users. The proposed modified algorithm shows the improvement in BER for high data rate applications of cognitive radio. So the Welch power spectral density and probability of reduction and probability of false alarm, so that is a PDF and PD, so are being compared using the FFT bar NFFT convolution and then periodogram. So and then the BER is compared with the Welch periodogram. So finally the BER performance analysis has been evaluated. Simulations are now done by using MATLAB. Let us discuss about the flow diagram of the process. So here this is the overall flow diagram. So the input signal and then filtering, analog to digital converter, FFT, squaring device, integrator, windowing, FFT, threshold and output signal. So here we are using the input signal. So input signal we calculated the GSM signal. So GSM means Global System for Mobile Communication, originally grouped for special mobile. So it's a standard for developed by European Telecommunication Standards Institute. So to describe the protocols for a second generation, that is a 2G digital cellular networks used by the mobile phone, there are 5 different cell sizes in a GSM network. So that is called a macro, micro, pico and femto, and also finally umbrella cells. So the coverage area of each cell varies according to the implementation of the environment. So this is the GSM signal of the process. And then filtering. So the signal it will be filtered. So the noise will be removed by using the BPF. So that is a band pass filter. So in the filtering process, here we applied the BPF. So that is a band pass filter. So band pass is an adjective that describes a type of filter or filtering process. So it is difference between from pass band, which refers to actual portion of a dual band filter has 2 pass bands. Band pass signal is a signal containing a band for frequencies not adjacent to 0 frequency, such a signal that comes out of band pass filter. Again, that is given to the A to D converter. So that is analog to digital converter. So here using the analog to digital converter, the signal is being converted to digital and then it calculated by the FFT. So the FFT is a fast Fourier transform. Algorithm computes a discrete Fourier transform of a sequence or its inverse. So Fourier analysis converts a signal from its original domain, so to represent in a frequency domain or vice versa. So the FFT computes such transformation by factorizing the DFFT matrix into product or space of factor and then squaring device. In the output of FFT, it should be squared the value. So and then integrated. So normally it should be the value is calculating the process of integrating the value of the integrator. So and then windowing. So in the windowing process, here we are using the Hamming window. The window, this particular coefficient was proposed by Richard. So Richard W. Hamming. So the here name is a Hamming. So the window is optimized to minimize and maximum. So that is a here near a side low. So given it is a height of about 1/5 of the Hamming window. So whatever it may be calculated, it will be calculated easily to determine the value. And then FFT magnitude, here we using the windowing value, it should be take the magnitude of the process. And then threshold have some definition as is for example greater than or less than. So that is the threshold value. Finally we calculating the output signal. So output signal, here we using input signal, finally calculating the output signal, BR performance of the process. So the periodic DFT even forms have only non-zero DFT coefficients and share the benefits of sparse frequency domain representing with higher generalities of the process. So finally we calculated probability of reduction, probability of false alarm, calculating the power spectral density of the signal, that is a periodogram, calculating the Welch power spectral plot, so that is calculating the Hamming window, and also bit error rate. So bit error rate, it should be reduced comparing to the existing one. So these are the overall flow diagram of the process. Yeah, let us discuss about the running procedure for the process. So click the main guide and then run. So it takes some time to display. So this is the main guide design of the process. So this is the error rate analysis for cognitive radio transmission. So click the file to get the input signal. So input signal we calculating the GSM signal. So GSM signal is a global system management. So click the input signal and then click that is in the TXT format. So that is a text format, and then open. So the input signal should be displayed. And the x-axis represented the frequency, and the y-axis represent the power or the frequency of the process. And then pre-processing. So in the pre-processing step, applying the filter. Here we using the Butterworth filter to reduce the noise of the input signal and also align the peak of the signal. So applying the filter, and then the bandpass filter, it should be applied. The bandpass filter is like in the frequency and power of the amplifier. And then PD versus PF. So that is a reduction probability and false alarm probability. So that is calculate the energy reduction of the process. So click the energy reduction, and then it's showing PD versus PF using the energy reduction. This particularly the probability of reduction is 0 to 1, and the probability of false alarm will take 0 to 150 of the process. Using the energy reduction, the primary signal is present or not, check the dialog box to calculating the value. So if the primary signal is present, the dialog box shows the primary signal is present. Otherwise the primary signal should be absent. So that is a process of PDF and PF. And then periodogram signal. So in the periodogram signal process, how the plot is using FFT and NFFT process. So this is the periodogram by using the formula. Similarly, it take a bit error rate for the process. So this is a periodogram plot for the bit error rate. So it's take 10 power 3. So it's very high to take on the total error rate. And then it's in proposed method we calculating the Welch process. So in the Welch process, it will be applying, this is the power rate and consumption rate. So in the bit error rate, it should be 10 power minus 1. So compared to the comparing periodogram and Welch process, it's take Welch process is, it should be very minimized. So compared to the convex process. So and then finally compare the error rate comparison. So error rate comparison means all the error, it should be compared with the for periodogram and Welch also. So this is a periodogram, conventional error function, convolutional code, forward error correction code in this process. And then compared to the periodogram signal, Welch is the best process to calculating the probability of bit error rate or bit error rate. So in this process, the error rate, it should be minimized compared to the periodogram. So Welch is the best method to reducing the error rate. So these are the overall running procedure for the process. Thank you for listening this video.